Hi everyone, and welcome to my talk, Designing an AI Platform to Scale. My name is Dino Bernicchi. I'm Head of Data Science at HOMECHOICE. HOMECHOICE is a home shopping and financial services group based in Cape Town. We have over 1 million customers and do about 3 billion in annual revenues. I'm also a consultant for Andrew Ng's deeplearning.ai, helping them review their course content before it goes live on Coursera. And a few friends and I have also co-founded a company called Fakerface, which is a company developing AI-powered creative apps. We've got one app on the Android App Store at the moment, so check it out. So let's dive into the presentation, the agenda for this afternoon. So we're going to look at AI platforms. What are the benefits of an AI platform, and then unpacking the components of that AI platform. What is MLOps? It's a buzzword that's been thrown around quite recently, so we'll just have a look at that and then realize that it fits in very nicely into an AI platform. And then just what are examples of an AI platform, and how do you decide whether or not to build or buy it? Is there a definitive answer in that question? Okay, so what is an AI platform? It's basically an easy way to standardize the end-to-end development of your AI solutions and also standardize the deployment of those said solutions. And if you standardize the end-to-end process of that, it makes it very reliable and robust. It makes it easy for you to scale AI throughout your business, and it also gives you the freedom to then not worry about coding these pipelines and worry more about testing new solutions. So it gives you the ability to rapidly prototype different things, without too much coding beforehand to do that. It also gives you the ability to monitor those solutions that are in production, to spot errors, to spot problems, and it just helps you manage a lot of solutions that are in production. And then it also just ensures that all of this modeling and effort that goes into that is reproducible and it's auditable. So what are some of the components of an AI platform? So you've got your data store that feeds into a feature store. Feature store is just a nice way to engineer data before it goes into the modeling process and house it there in a nice format. The modeling process is obviously a core component of an AI platform, and there's a lot of places that you can automate, how those models are trained, how it selects features for the models, how it fine-tunes the hyperparameters for the models. And then that model gets saved into a model repository. It's a good idea to have that in a standardized format. It makes it easier then to go back and look at previous models that have been trained or to push models into deployment. A production manager helps that deployment process. It also helps with retraining models, which is very important to avoid any sort of model degradation in performance or model drift. And then standardizing your integration pipelines is very important, because that helps the rest of your business more easily integrate with AI solutions. And then last but not least, and probably the most important, is the Uplift calculation engine, which is just a fancy way to say, how do we review the results of an AI solution that's in production? So how do we A/B test it? How do we see how it's affecting different drivers? And how do we calculate the actual profits from the solution and see if it's working? So let's unpack the feature store a little bit more. Why do you actually want a feature store in the first place? I think the reason why you want it is it's a nice way to architecture the data before it goes into model ingestion. It also standardizes all of your data pipelines before the modeling process. So if you do this, it becomes quite easy to leverage features you've already engineered for additional solutions. So think about it. You create customer features, use that in one model. You then want to launch a new model. You don't want to re-engineer all of those features. A feature store allows you to quite easily save those features and then use them again in the future, and also update those features as time progresses. So what would a feature store typically look like? So you've got your data. That data will go into a feature engineering process. That's where we actually create the features, and you can also have quality control steps along there. Once you've got those engineered features, you would put them into different groups. So you would have customer feature groups, transaction feature groups related to your website or product. And then you have rules to pull those feature groups into different modeling pipelines. So you might have a propensity model that relies on customer and transaction feature groups. You would have rules then to include those two feature groups together and maybe exclude certain data or have other business logic there. And then the data would be prepped for model ingestion. And model ingestion could mean training or inference, or it could go to the Uplift calculation engine to actually test whether or not the solution is working in production post-deployment. The next component is the modeling process. Why would you want to automate this? Well, quite simply, you would rather have your data scientists experimenting and testing different models or configuration in models and less time actually setting up those processes. So this AutoML platform allows that. It allows your data science to experiment more, but spend less time setting up those experiments. So typically how this would work is you would be consuming data from your feature store, and then you can set up a training configuration file. So in that file, you could say, okay, I want to test these different models, XGBoost, neural nets, and I want to use these different feature selection techniques, and I want to use these different hyperparameter selection techniques. And then you can leave the machine to work over the weekend or the week to run these different models, and then you can just go at the end and actually look at the results after you've done that. So training configuration file, the system then just runs by itself. Make sure that it's using the most state-of-the-art models that are open sourced. And then your data scientists can spend more time looking at those results and seeing, well, where is the model working? For what subgroups is it working? Is it not? Do I go back to the training configuration file, play with that, hopefully get a better result the next time? And then at the end, your data scientists might be presented with hundreds of different model configurations and different results for all of those model training runs. And then the data science can either have a system to automatically select the best model, or can manually look through that and select the best model to push into production. Once the data science does that, the model is actually saved. Everything here is actually saved in case you want to reproduce any sort of training result. So let's take a look into that model repository. And why is it important to have that? Well, just so that any sort of training that you've done, all the artifacts and models in that training run are saved. And usually this just takes a couple of megabytes, so you might as well do save it for every sort of training run that you have done in case you ever need to go back to it. What's normally saved in here? A feature schema, so you know exactly what features were used in the training process. Typically we save just a small sample of the test data so that we can use it almost as a bit of a litmus test, or if we deploy into a foreign environment, we can run the test data through just to make sure that the model is running correctly and we get the predicted results that we expected. All the data pipeline code can be saved. The training configuration file, obviously very important. All the model parameters post-training can get saved. The actual training results, so what was the accuracy and all the other metrics, so that you can go back to that. We save it into a log so that we can pivot that information and display it in various different ways, and we can track if there's been degradation over time from different training. And then saving all sort of one-hot encodings related to the data, any sort of transformations related to the data, and then any sort of models that were created in that training run. The other thing that we do is we hash all of that information. The reason we do that is, again, if we deploy into any sort of foreign environment, if we've used, say, a CRC32 hash, we can re-enhash the model and then check it against our saved hash just to make sure that we are using the model that we think we're using in a production environment. All the model pipeline code obviously saved. A snapshot of the environment, again, so if you are deploying in a foreign environment, you can compare the environments to make sure that there's no sort of dependencies that are missing or versions that are out of sync, which might cause problems. And then last but not least, any metadata related to the training is saved. Next up, the model production manager. So why would you want this? So it's just an easy way to monitor when a model retrains or when it deploys or when it runs batch inference. It's basically a scheduler, but if it's part of your AI platform, it's a nice way to tie together all the moving components to make sure that they're executing when you expect them to execute, and a nice way to monitor that things are executing as expected. So some of the things that Task Manager can execute is a deployment process. So let's say you want to deploy a model now that you've trained. What it would do is read from that model repo. It would look at all those artifacts. You could determine the percentage and maybe the channel that the model then rolls out to. And then this deployment manager would automatically either do an internal or external deployment, batch inference or API or stream. Batch inference just means that at a certain cadence, like 1 million customers will be scored using the model. External deployment of an API or stream means one customer will be scored at a time. API means it'll be scored almost in real time. So the service will go fetch the model score for a customer in real time and run the model. Streaming means that as data lands in an environment, the model will see that new data has arrived and create a new prediction, and then some other process can read from that prediction. If the task manager is executing a batch inference process, it would basically read from that model repo and then run through that entire process. So do all the checks to make sure you're using the correct environment, the correct data, make sure you're using the correct models, encode and transform the data as need be, and then actually execute the inference. And in that process, you can also check things like your scoring drift. And then last but not least, maybe one of the most important is actually execute a retraining process. So again, read from the model repo, and you'll have in the model repo that training pipeline and the training configuration file. So the model can the task manager can re-execute that training process when needed. Okay, so I spoke about standardizing integration. Just wanted to go into a little bit more detail here about that. And there's 3 different ways that you could integrate, as mentioned. So batch inference, API, or stream. Batch inference, what we do is we make sure that we standardize the format. So if we're making predictions at a customer level, it's the custom identifier and then the prediction, which is maybe a number between 0 and 1. So a probability that event's going to happen in the future. So we standardize the format, we standardize the location that we drop those batch inference predictions at, and then also we standardize some of the business logic around that. So then it's quite easy for a developer to say, okay, well, I need these predictions, I go to this location and I consume them, and this is the logic on how to interpret that prediction. For an API, it's similar, but a little bit different. We've got a process to automatically create an API. We've got all the saved model objects and everything that sits in the model repository. We've got a separate process that will feed off of that and create a Flask app, which we can then deploy into a Kubernetes container and host it in AWS or wherever needed. And then we make sure that the location of that is pretty standardized. So then we can say to the devs, okay, there's an API that you need to integrate with. Here's the location. Here are the puts and call methods associated with that API, and this is the logic around how to interpret the results that you get back from the API. The stream is very similar to the batch inference. Again, it's just a table format, so we confirm the format, the location, and the logic behind that. And the nice thing about this is once you've done one of these integrations with your dev team, if you keep using the same format going forward, then it's quite easy for them to integrate into the next solution and the next solution and the next solution. So let's have a look at the Uplift calculation engine. Why would you want an Uplift calculation engine? So it's a good idea to A/B test almost everything you do in business, especially when you're deploying large scale AI solutions in your organization that has massive effect on your business processes. So if you are deploying, for example, something into your call center that improves your right party connect, it's a good idea to A/B test that against your existing processes just to make sure that you are moving the needle in the correct direction and there's no sort of unintended consequences that you're not thinking about. So best way to do that is to do an A/B test. Some customers are affected by the solution, other customers are not affected by the solution, and then you track sort of defining metrics across those 2 groups. An Uplift calculation engine is just a nice way to structure that process and to automate some of the steps in that process. I'll explain in a little bit more detail. So if you've got a solution that is making predictions for your call center, so you'll have those probability output scores for all of your customers. You can then create a test in a holdout group. What we prefer to do is do matched groups. So even if you randomly split those customers, make sure that you do run sort of statistical matching techniques over those customer groups and look back, 3, 6, 12 months to make sure that those groups are representative of one another. We do a lot of pre-period checks just to make sure that there's no outliers in those groups, and then actually split them into your test and your holdout. The test group will get the effect of the AI solution. So if it's in the call center, in improving the right party connect by recommending a specific number to call the customer on, those customers then actually go through that process. The holdouts just go through the normal business process, so they won't be recommended a new number to be called on. Post the campaign, or at the end of the week or the month, if this campaign is running continuously, there's some post-period checks. Again, just to check that there were no sort of outliers. Run your statistical checks again to see how those customer groups have changed. And then that goes into your monitoring. So if there is a difference in those two groups, is it significantly different? And then what was the difference in, was there a difference in Right Party Connect? Was there a difference in sales? Was there actually an improvement by using the model? It's also a nice way to test your predictions versus what actually happened, and then monitor any sort of like a model drift. Okay, so we spoke about the AI platform. Now, what is machine learning operations? It's a set of practices to deploy and maintain models in production reliably and efficiently. And you can see how an AI platform actually enables MLOps quite easily. That platform makes it quite easy to deploy and maintain models in production. It's because it's an end-to-end monitored process, it's reliable and efficient, and it ensures the continuous operation of your AI solutions in production. And what's quite nice is at all those different components and each of those pipelines, you can set up quite nice performance monitoring. So you can monitor your features, your feature engineering, you can model your training, your retraining, you can monitor your model repository, pushing models in production, and that can be outputted into nice sort of monitoring metrics. Some examples of players in the AI platform space. So you have your big players like Amazon, Microsoft, Google Cloud, who have MLOps and AI platforms buried within all of their other services and products. And then you've got players in the market that build specific AI platforms like Dataiku, DataRobots, and H2O. They each comes with their pros and cons, and it really depends on your specific use cases and what you are looking for. And we'll talk about this in my last slide. So here's the last slide, build or buy considerations. I saved my worst slide for last. It's a lot of text here, but yeah, there's no right answer to build or buy. I'd say maybe take a screenshot and then go through these questions, or chat to me if you are interested in talking. But there's a lot of things to consider around build or buy, and a lot of these relate to any sort of software questions anyway. But let's maybe just go through this quickly. So there's a couple of things to think about at a high level. Integration. If you build it, you can make it fit for purpose. You've got full access to that code. You can build what you want, basically. If you're buying, you have to see whether or not they can integrate. How much effort does it require to integrate, and where does that data flow? Do you want your data to leave your environment? Do you want your data to flow to Europe or Hong Kong or America? It's something to consider. What features the solution has. So obviously if you build it yourself, you can just build the must-haves. You don't have to have any sort of bloat. Do you actually have the skills to build it? That's a tough question. If you buy it, does it include all the must-haves that you require? And are there any free nice-to-haves, which is a good consideration? And then always ask these guys for their feature roadmap. See where they're going with the product, and if it's where you would like to see the product in 2 or 3 years' time. Performance, I'd say these all relate to whether you build or buy it. But how do you scale with your needs over time? So if you expect your customers to grow, hits on your website to grow, how does the hardware, software, and people scale? Is there an exposure to risk, downtime, and do you have service level agreements? This is internal or external. Design, best practices are open source, but if you are building it yourself, more likely you're going to prioritize functionality over the UI and the ease of use. If you are buying, you definitely want to make sure that whatever you're buying is following design best practices. And is the UI clear, and is it an easy to use product? Documentation, training, and support. So if you're building it, who's going to use the platform? Is it a data scientist? Because if it is, most likely you don't need too much training and support or documentation. But if you want extended people in your organization to use it, then it becomes a bit of a question mark. If you're going to buy, obviously just find out what's included. Speed to market, if you build it, it's definitely going to take you a few months. At HomeChoice, it took us probably about a month and a half to get a prototype up and running of the whole AI platform. And then over the next year, as we were developing solutions and pushing into production, we were making fine improvements on the AI platform. And then after about a year, we had something that was fairly polished. If you are going to buy, you'd most likely be up and running in a couple of weeks. So it's something to consider, because you'll be much quicker to market if you buy, especially if you are lacking the skills to actually develop yourself. Cost and the ROI. It's quite difficult to estimate internal development costs, I think. Often how long is a piece of string? So how long do you want to spend working on this thing? And also you're going to lock up some of your resources into developing this platform. Whereas if you buy, it's obviously quite reliable and easy to understand the costs associated with the service, and usually it's a monthly or annual rental agreement. And then longevity risks. So if you've got some key resources inside the organization that build your AI platform, there's obviously some key dependency risks there, and there might be some technical debt if you take some shortcuts to build the solution quickly and don't sort of invest enough resources to build something that will last a longer time. If you buy, there's similar considerations, so if you go to some of these smaller players, are they a fly-by-night service provider? Are they going to be around? Especially if you fully integrate into their service, it would be quite a disaster if in a year or two's time they sort of pull the plug and close their company. And then also something to consider is, looking at their roadmap. Are your needs and their development plans going to diverge? Because if they are, then that could also be a problem. So that brings us to the end of the talk. I hope you learned maybe one or two new things. And if you want to chat about any of the stuff, please reach out. If there is time for questions, I'm sure I'll be in the chat somewhere to answer those questions. Thank you very much.